All right, so let's talk about physical and chemical properties. So, physical properties are properties that you can observe just by looking at something, smelling it, basically using your senses, right, to observe something. So, color, length, volume, like how much space something takes up, and opacity, so whether you can see through something or not. So, all of these things are physical properties, things that you can observe with your senses. So, chemical properties, observed and measured as sample changes chemical identity. So, for these, you can't really observe with your senses. These you really wouldn't be able to observe unless you did some kind of chemical reaction to the actual substance, right? So this you can't really observe, and some examples of this are like acidity. And so acidity has to do with how many hydrogen, positive hydrogen atoms, and how many OH, so hydroxide molecules are in there. Not important, but just it's the chemistry that it's made up of. Reactivity too, right? It's like the chemistry of something and how it's chemically made determines how reactive it is. Flammability, same thing, right? A piece of foil paper won't really light on fire, but a piece of regular paper will light on fire because of the chemicals that it's made up of and how they are made up. Toxicity, same thing, right? Like grapes. Grapes are not poisonous to people, but if dogs eat it, they're poisonous to them because of the chemistry of the dog and the chemistry of the grape. And so, again, physical properties you can observe with your senses, chemical properties you cannot. You have to do some kind of chemical reaction to observe those, right? So some examples right here: physical properties, things like viscosity, malleability, those kinds of things you can feel, touch, smell. I remember when you're talking about a chemical property, these you can't, right? It's the chemistry of what it's made up of, and you can't observe these without some kind of chemical reaction happening, right? And so, but then you have here. Oops, let me go back to this right here. A physical change. Remember, physical change is just you're making it look different, but the what it's made up of is does not change, right? So for example, water, right? Water, when it goes below 0 degrees Celsius, it turns into a solid, but it's still H2O, right? And then it goes above 0 degrees and it turns into a liquid. It's still H2O, but it's liquid now. And then if it goes above 100 degrees Celsius and it turns into a gas, into steam, it's still H2O, but now it's just in a gas form, right? Same thing with a big piece of paper. You tear it into little pieces, but it's still paper, right? It's just in smaller pieces. So these are examples of physical changes. Remember, chemical properties you can't observe unless some kind of chemical reaction happens. But when it comes to chemical changes, there are some signs that let you see something as a chemical change, right? If it changes in color because of a chemical reaction, if it is gases are formed, like with the effervescent tablets that we saw, solids are formed, like when milk rots and it goes bad and little solid chunks start to form. That is because of a chemical reaction. And then, like also with the tablets, whenever we put them in there, it would absorb that heat energy from the water and it would make the water get colder, right? So chemical changes occur when a substance reacts and then it forms a new substance.